What type of galaxy is that? It's a spiral galaxy. This is spiral arm galaxy. This is much like the galaxy that we live in, the Milky Way galaxy. It is, of course, not a picture of the Milky Way galaxy. We do not have this vantage point for our own galaxy. Some statistics about our galaxy. The distance from the Earth to the center of the galaxy is 30,000 light years. We're around here, maybe somewhere around here. So this distance right here is about 30,000 light years. Light year. What's a light year? Think.
How far light goes.
Notice it's a distance. It's not a time. A misconception here because it has the term light year in it. It sounds like it's a time. It is not. It is a distance. It's the distance light travels in a year. So the distance to the center of our galaxy from Earth is 30,000 light years. It is estimated that in our galaxy, the Milky Way galaxy, which is a pretty typical galaxy, we have approximately 2 times 10 to the 11th stars in our galaxy. That's 2, 0, 0, 0, 0, 0, 0. I got lost. Let's see. 1, 2, 3, 4, 5, 6. Yeah, I get it. There are approximately 200 billion stars in our galaxy. Here's another galaxy. This is actually another spiral galaxy. And what's interesting about this one is the galaxies should be flat. The spiral galaxies should be flat. And this one is not. It actually kind of shows a slight curve like this. And what we think happened to this galaxy was that at some point in its past, it ran into another galaxy, which would be a bummer. We don't want to go through that. Although what's funny about that is that the stars themselves probably wouldn't run into one another. They would just kind of go through, but then we'd have all sorts of issues with orbits. And it would be ugly. Anyway. In 1996, the Hubble Space Telescope. What they did was they took the Hubble Space Telescope, if this will play good, and they pointed it at a spot in the sky. Now, they picked a particular spot in the sky which had nothing. So you can see right here, and we're going to start zooming in just a moment. So we're going to zoom in on a spot in the sky. What they did is they picked a spot in the sky that, according to the telescopes that they had used previously, had nothing. It was just a black spot. And the idea was, hey, let's look at emptiness and see what we can find. And they pointed it there for 11 days, which is a heck of a gamble if you think about it, because the Hubble Space Telescope is actually quite expensive to run, and to take 11 days and just say, hey, we think there might be something useful to see here where we don't see anything. Let's see what they found. Okay, so what we're going to do here is we're going to zoom in slowly but surely. This is the night sky, and we're going to see a rectangle, which is a telescope. So every telescope that we get, we're going to be able to see slightly farther away from the planet. And we see another telescope, and finally, this is the Hubble Deep Field View telescope. So this is the Hubble Deep Field View. They pointed it at nothing for 11 days, and this is what they found. Remember, there was nothing here? Wait, what are these? Galaxies! Oh look, a bunch of galaxies. Look at that, will ya? We've got a whole bunch of galaxies. Okay, well, I don't know, our galaxy is pretty normal, so we'll say, let's say this one has 200 billion. Somebody add 200 billion, 200 billion, 200 billion, 200, 200, 200, 200, 200, 200, 200. Everybody got it? I'm trying to add the number of stars. Remember, this is like that spot in the sky, which has nothing. Now, the fun thing about this is that these galaxies are actually 13 billion light years away. 13 billion light years. Now that means not only that's how far away they are, but that's how long it took the light to get to us. Which means that we're actually looking 13 billion years in the past when we look at these galaxies. Right? Because that's how long it took the light to get here. Think about that one. How old's the universe? 13.7 billion, according to recent estimates. 13.7 billion years. We're getting very close to the beginning of the universe right here. And a couple years later, 2004, they did this. Nope, not that one. They took this image, combined with the redshift data. Now, redshift, we have already looked at the Mercury vapor discharge length, right? And we saw various lines. They were at specific wavelengths, right? If an object is moving away from you quickly enough, the color coming from that object will be shifted. If it's moving away from you, it will be redshifted. If it's moving away from you, it'll be shifted toward the blue. So when we look at these stars, we can figure out how quickly they're moving away from us, and hence how far away they are. And in 2004, what they did was they took that information and they plotted where these objects would be relative to us and created a visual representation of flying through those galaxies, which are 13 billion light years away. And while you are pondering the billions and billions and billions and trillions of stars that are passing you by, I want you to think to yourself, am I alone in the universe? Do I know the answer to that question? Are we alone? I don't know. But does it seem logical that we would not be? I mean, it seems logical, right? So let's put it in perspective. I got maybe 2 minutes. Let's put it in perspective. How long have we been sending out electromagnetic waves saying, hey, everybody, we're here, right? Because we've been sending out radio waves, right? Right now, there could be other species, other aliens listening to us. Anybody know what they would hear first? What they would see? Actually, we'll go with what they would see first. First television broadcast. Hitler. The Olympic Games, I can't remember, I should know which one, 1939 maybe, 1940. Olympic Games, he wanted to, the Hitler regime wanted to show their dominance, and they broadcast on television the Olympic Games. That's right, right now, there are extraterrestrials that are listening and watching. They're seeing Jersey Shore, and they're saying, I don't want to visit these people. Ladies and gentlemen, people, if you didn't feel small before, hopefully I've helped you feel small. I hope you enjoyed Modern Physics.